All right, y'all, this is a review for the Carnegie checkpoint for topic 1. Let's get into it. Number 1, what's the equation of a line that's parallel to y equals negative 5x plus 3 and passes through that point 3, 1? So since it is parallel, we're going to keep the slopes the same. So that means the slope is negative 5. And we're not going to change it because it's parallel. And then our point is 3, 1. So that's going to be our x1, y1. And we're going to use point slope formula because we got a point and a slope. What a concept. We're going to go ahead and replace. So I'm just going to duplicate that. All right, so we're going to replace the y1, the m, and the x1 with 1, negative 5, and 3 respectively. All right, now we could leave it like that. That's legal. It's perfectly legal. I don't think, it depends on what the question says, but this would just be the answer in point slope form. So that's fine. I'm going to keep going for the sake of, knowing how to do slope intercept form though. Go ahead and distribute the negative 5. So that's going to give us y minus 1 equals negative 5x plus 15. Then we're going to add the 1 to both sides, leaving us with y equals negative 5x plus 16. Da, 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 da. That is slope intercept form. All right, so you see the difference between the point slope form and the slope intercept form. Number 2, write the equation of a line that's perpendicular to y equals negative 2 fits x minus 1 and passes through the point 2, negative 8. This time we're doing perpendicular slope, and that's important. That's an important distinction because it changes things. The original slope is negative 2 fifths, so the perpendicular slope is going to be positive 5 over 2. So that's what we got to use. This will be our x1. This will be our y1. Once more, we will start with the point slope formula. If I can grab it. Yeah, I did the best I could. Okay, let me get the 1. And we're going to substitute y1 is going to be negative 8. So the slope is 5 over 2. And then x1 is 2. So we're going to go ahead and distribute. So we're not going to leave it in point slope form in this particular problem. Do not forget when you have a double negative, add a line, change the sign. So that'll be y plus 8. And we're going to distribute, so that'll be 5 over 2x. 5 halves times 2 is just 5, so it's minus 5. We're going to take away 8 from both sides to get the y by itself, and that'll leave us with y equals 5 halves x minus 13. Jazz hands. Number 3, write an equation for a line that's parallel to x equals 5 and passes through this point. All right, so parallel means it's going to have the same slope. If it's x equals, that means it's VUX. All right, so if it's parallel, we're still going to stick with VUX. So keep that x equals, and this is our x coordinate right there. So that's really it. And number 4, write an equation for a line that's perpendicular. So perpendicular means we got to change the slope. So perpendicular to the x-axis. If that's the x-axis, then perpendicular would be vertical. So that's, again, going to be VUX. So this is going to be x equals 4 because 4 was the x-coordinate of the point we need to go through. Number 5. All right, my favorite, the rigid motions. Don't forget rigid motions would be translation, reflection, rotation. So use those in your descriptions. And I will say this, over-explain. If there's an inkling in you that's like, okay, this might not be enough, write more. Over-explain what you're trying to say. All right, so there are many ways we can do this. This is the way that I'm going to do this particular problem. I'm going to start with this segment. So I'm going to translate the segment from, what's that, -1, 2 to 2, -1. Okay, -1, 2, 2, -1, just checking. And I'm going to have to go up to, right to, in order to get it over here. All right, so the new segment would be 0, 3, and 3, 0. Okay. All right. And then for the shorter segments here, I'm going to translate -1, 2. Oh, the segment, my bad. -1, 2, and 3, 0. No, 0, 3. Brain fart. Just double checking. And we're gonna have to translate it. Let me use a different color, I guess. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're gonna have to go down 6 and to the right 6 to get it to its new spot. So down 6. And right 6 to form the segment. 2, -1, 3, 0. All right, fantastic. So I included the rigid motion, I included the vertices, the coordinates, and how the thing needed to move. All right, go ahead and try number 6. My suggestion is that you use this one to start with. And since all the sides are equal, you should be good to go. Number 7. Use a compass and a straight edge to duplicate each line segment. Well, this line segment. So, I'm not going to hold you. I can't use a compass right now. I'm going to have to use circles. Oh, that's not a pen. So, I'm going to draw this here. Sure. All right, so what I'm going to do is draw a circle whose diameter is XW. Okay. Then that looks a little bit off, doesn't it? Okay. Then I'm going to simply, oh, I forgot my endpoint over here. I'm going to take that circle, put it on this new line, make sure it's lined up, and that's pretty much it. That's my answer right here. And if I were to erase all of that, then there you go. Beautiful. Next, construct a line perpendicular to line L through point B. All right, I'm still going to use circles because I ain't got no choice. I'm going to make a circle around point B, but I'm going to have to center it. So let me use my ruler. Oh, shucks, I didn't mean to do that. Okay, so let's see. Very nice. All right, so B's in line with Okay, good. B is pretty much in line. Looks good. All right. Once I do that, I don't really need the rest of the circle, so I'm just going to get rid of that. You can keep it. I just don't want to. All right, I'm going to change that color too because I want my final answer to be black. All right, now I'm going to have to draw a circle from these two intersection points. So let me do that now. And I have to make sure that the circle goes past halfway when it's centered properly. All right, it's past halfway. Yes, it is. Barely, but it is. Okay. All right, there we go. All right, so I got my two circles here, and then I'm just gonna draw a line that goes through. Hold up, that's a little bit off. Okay, there we go. This is not too bad. All right, so again, I could erase the rest of this and it would just give me the arcs instead of the full circle, but it doesn't matter. It's cool either way. Construct a line that's perpendicular to AB and it goes through point X. So the first thing I need to do is draw a circle that is centered around X. All right, so that looks good. All right, I'm gonna go ahead and erase the parts I don't really need, which honestly is all of that, but I'll keep that. It doesn't really matter though, as long as you have the distance from X on both sides, that's the same. And then I'm gonna draw the intersection points here and here. Ignore the A and the B, we don't need the A and the B. And then we're gonna draw two circles, one for each intersection point and center it on the intersection point. I would like to go a little bit further than that though. Okay. Alrighty. Okay, and then just draw a line through the intersections here. The intersections of the circles, I mean. Okay, it's a little bit off over here. All right, I'm gonna call it there. Okay, and again, you could use the full circle or just the arcs like we've been doing. Fantastic. Next, perpendicular bisector. So I'm gonna go ahead and draw two circles this time. One with G as the center. I'm not gonna hold you, it's really hard for me to tell if this is centered or not, so let me move this. Okay, that looks good. That does not. Oh, I was like, what happened? Okay, a little bit off. All right, that looks decent. And then I'm going to duplicate. Make sure that your circle goes past halfway across the line, otherwise this will not work. All right, let's be sure because this one, ugh, that's way off. Okay, great. Okay, that looks good. All right, so my circles are centered on the endpoints. All I gotta do is draw a line that goes through this that point of intersection and that point of intersection. All right, and it's a little bit off. Sorry, it's bothering me. Okay, great. All right, it's perpendicular. We're done. Again, you can leave the full circle or you could just use arcs. It's fine either way. All right, I'm only gonna duplicate one angle. You can try the other. I'll do the big one because it's easier. All right, first up, I'm just gonna put a point right there, and then I'm gonna draw a line segment over here in some random direction because it doesn't really matter. I want to draw a circle centered around that point I just drew on the original one. Okay, I'm gonna duplicate that and do it over here. All right, I don't need the whole circle, but you can use the whole circle if you'd like. Okay, then I'm going to get the distance. This is gonna be weird, but it's all good. I can't use the compass to do this because I don't have a compass, so I'm just gonna do it like this. We get creative. All right, I'm gonna duplicate this line and do it over here. Oh wait, no, I can't do that. I can't do that because the direction is off, so hold on. I'm gonna put a box around it so I can rotate it without changing the size of the line. All right, I'm just gonna keep finagling it. Oh, never mind, finagle no more. Perfect. All right, come on. All right, once I got that, I can see that this is the intersection point that I need right here. And that's where I'm gonna send my line segment. And that's that. Jolly good.